According to the National Electrical Code, Section 225.30, service equipment shall supply the entire premises. Overcurrent devices shall be readily accessible. This means the existing 200 amp service can supply the new building if both are considered part of the same premises. The code requires overcurrent devices, such as circuit breakers and fuses, to be readily accessible for maintenance and emergency situations. While the existing panel may not be directly accessible from the new building, this arrangement isn't explicitly prohibited by the NEC. However, there are practical considerations. Firstly, long branch circuits can cause voltage drop, especially with significant loads. It's crucial to select appropriate wire sizes and circuit lengths to minimize voltage loss. You can calculate voltage drop using voltage drop calculators available online and through various apps. Secondly, the overcurrent devices in the existing panel might not provide adequate trip protection for circuits in the new building. Consider installing additional overcurrent devices within the new building, such as fuse blocks or supplementary overcurrent protection devices, to ensure proper protection. Thirdly, having all branch circuits for the new building originate from the existing panel can complicate isolating and troubleshooting electrical issues in the new building. It's generally not recommended to power all the branch circuits for a new building from an existing panel, even if the code doesn't explicitly forbid it. Installing a sub-pole or a separate electrical service in the new building is a better approach. This provides more direct access to overcurrent devices and allows for better isolation of electrical systems. When dealing with electrical installations between buildings, several NEC articles come into play. Article 225 covers outside branch circuits and feeders. Article 300 addresses wiring methods. Article 310 focuses on conductors for general wiring. Article 408 covers switchboards and panel boards. Article 250 discusses grounding and bonding. The ampacity of conductors must be determined according to NEC Table 310.16, considering the conductor's insulation type and the ambient temperature. Voltage drop should be limited to no more than 3% for branch circuits and 5% for feeders, as recommended by the NEC. Grounding and bonding are critical for safety. All metallic components must be properly grounded to provide a low impedance path for fault current. Grounding electrode systems should comply with NEC Article 250. Sizing the grounding electrode conductor according to NEC Table 250.66 is essential. Bonding jumpers are used to connect metallic components to the grounding system. The size of the bonding jumper should comply with NEC Table 250.102. Overcurrent protection devices should be sized according to the ampacity of the conductors they protect. Circuit breakers and fuses must interrupt fault currents safely. Short circuit current ratings of overcurrent devices must be sufficient for the available fault current at their location. Selective coordination of overcurrent devices ensures that only the faulted circuit is interrupted, minimizing disruption to other circuits. Arc fault circuit interrupters, also known as FSIs, are required in many branch circuits to protect against arc faults. Ground fault circuit interrupters, also known as GFCIs, are required in wet locations to protect against ground faults. Surge protection devices, also known as SPD, protect against voltage surges caused by lightning or other events. SPD should be installed at the service entrance and as sensitive equipment. Wiring methods must comply with the NEC. Conduit, cable, and other wiring methods must be suitable for the environment. Underground wiring must be protected from physical damage and moisture. Direct burial cables must be rated for direct burial. The depth of burial must comply with NEC Table 300.5. Conductors must be identified by color. White or gray is used for the neutral conductor. Green or bare copper is used for the grounding conductor. Other colors are used for phase conductors. Electrical boxes must be sized according to the number and size of conductors they contain. Box fill calculations must comply with NEC Section 314.16. Electrical equipment must be listed and labeled by a recognized testing laboratory. Equipment must be installed according to the manufacturer's instructions. Working space must be provided around electrical equipment. Clearances must comply with NEC Section 110.26. Access to electrical equipment must not be obstructed. Equipment must be protected from physical damage. The environment must be suitable for the equipment. Temperature, humidity, and other environmental factors must be considered. Regular inspections and maintenance are essential for electrical safety. Electrical systems should be inspected periodically by a qualified electrician. Maintenance should include tightening connections, replacing damaged components, and testing overcurrent devices. Documentation is important for electrical systems. Electrical drawings, panel schedules, and other documentation should be kept up to date. Documentation should be readily available for maintenance and troubleshooting. Using a subpanel in the new building offers several advantages. Firstly, it provides a dedicated point of distribution for the new building's circuits, simplifying future additions and modifications. Secondly, it allows for better protection, coordination. Thirdly, it makes troubleshooting easier by isolating the new building's electrical system from the existing building's system. When installing a subpanel, ensure it is properly sized for the anticipated load. Calculate the total load of the new building circuits, including both connected and future loads. Select a subpanel with a sufficient ampacity rating. The subpanel must be properly grounded and bonded. Connect the subpanel's grounding electrode conductor to the building's grounding electrode system. Bond the subpanel's enclosure to the grounding electrode conductor. The feeder conductors supplying the subpanel must be sized according to the ampacity of the subpanel. Use NEC Table 310.16 to determine the appropriate conductor size. Overcurrent protection must be provided at the source of the feeder conductors. The overcurrent device must be sized according to the ampacity of the feeder conductors. When running conductors between buildings, consider the following. Firstly, use approved wiring methods. Conduit is often the best choice for underground runs. Secondly, protect conductors from physical damage. Use rigid metal conduit or intermediate metal conduit for exposed runs. Thirdly, ensure conductors are properly supported. Use appropriate hangers and supports to prevent sagging. Fourthly, seal conduit to prevent moisture from entering. Use duct seal or other approved sealant to seal conduit openings. Fifthly, provide expansion fittings. Expansion fittings allow for thermal expansion and contraction of conduit. Sixthly, consider lightning protection. Install lightning protection systems to protect buildings and equipment from lightning strikes. Lightning protection systems should comply with National Fire Protection Association Standard 780. Here are some common wiring methods for running conductors between buildings. Firstly, underground conduit. This is a common method for running conductors underground. It provides good protection from physical damage and moisture. Secondly, overhead conductors. This method is suitable for short spans where underground installation is not practical. Use weatherproof conductors and hardware. Thirdly, direct burial cables. This method is suitable for underground runs where physical damage is not a concern. Use cables that are rated for direct burial. When selecting conductors, consider the following. Firstly, ampacity. Select conductors with sufficient ampacity for the load. Secondly, insulation type. Select conductors with insulation suitable for the environment. Thirdly, voltage rating. Select conductors with a voltage rating suitable for the system voltage. Fourthly, conductor material. Copper and aluminum are common conductor materials. Copper has higher conductivity but is more expensive. Fifthly, conductor size. Select conductors that are large enough to minimize voltage drop. The NEC provides guidelines for calculating voltage drop. Use voltage drop calculators to determine the appropriate conductor size. When installing overcurrent protection devices, consider the following. Firstly, interrupting rating. Select devices with an interrupting rating sufficient for the available fault current. Secondly, time current characteristics. Select devices with time current characteristics suitable for the application. Thirdly, selective coordination. Coordinate over current devices to minimize disruption during faults. Fourthly, arc fault protection. Use arc fault circuit interrupters for branch circuits serving dwelling units. Fifthly, ground fault protection. Use ground fault circuit interrupters for circuits serving wet locations. When grounding and bonding electrical systems, consider the following. Firstly, grounding electrode system. Establish a grounding electrode system that complies with the NEC. Secondly, grounding electrode conductor. Size the grounding electrode conductor according to NEC Table 250.66. Thirdly, bonding jumpers. Use bonding jumpers to connect metallic components to the grounding system. Fourthly, equipment grounding conductor. An equipment grounding conductor with all branch circuits and feeders. Fifthly, isolated ground. Use isolated ground receptacles and circuits where necessary to reduce noise. Remember to always consult the latest edition of the NEC and local codes for specific requirements. Engaging a qualified electrical contractor is highly recommended for any electrical work, especially when dealing with installations between buildings. The contractor can assess the specific conditions, ensure compliance with all applicable codes and standards, and provide a safe and reliable electrical system. The contractor will consider factors such as the distance between buildings, the soil conditions, the anticipated loads, and the local climate. They will also coordinate with the local utility company to ensure proper service connections. Consider a situation where the new building is a small office space adjacent to an existing chapel. The office space requires lighting, receptacles, and a small HVAC unit. The existing chapel has a 200 amp panel with available capacity. Instead of running all the branch circuits from the existing panel, a 60 amp subpanel is installed in the new office space. This subpanel provides power to the lighting, receptacles, and HVAC unit. The feeder conductors supplying the subpanel are sized according to the 60 amp rating of the subpanel. Overcurrent protection is provided at the source of the feeder conductors. The subpanel is properly grounded and bonded. This arrangement provides a dedicated point of distribution for the office space, simplifying future additions and modifications. It also allows for better protection, coordination, and makes troubleshooting easier. Always remember safety first when working with electricity. Turn off the power before working on any electrical circuits. Use appropriate personal protective equipment. Follow all applicable codes and standards. If you are not qualified to perform electrical work, hire a qualified electrician.